this video, I'll be showing you an activity which you can use to introduce students to the concept that heat is the jiggling of atoms and molecules, and how this jiggling relates to the properties of different states of matter. This will help students to understand at a molecular level how solid ice transitions to liquid water and then to gaseous steam as it heats up, and vice versa. For this activity, students will work in small groups. You will need to provide students with a medium-sized sealable container which can be seen into. Here, we're using a picture frame, and we also need a handful of beads. We're using these craft beads. Ask the students to place the beads into the container and seal it. The beads represent atoms or molecules in this model, and by shaking the container, we are able to jiggle the beads, representing heat vibrations. In this model, the beads are being held together due to the effect of gravity. But it's important to remember that in reality, it's electrical forces which hold solids and liquids together. This activity is best performed by holding the container at a shallow angle, so that we don't have to shake it too hard. Ask your students to shake the container at different intensities and to identify how the behavior of each state differs. Let's start by shaking it quite vigorously to represent a gas. Slow down to represent a liquid, and then slow right down to represent a solid. Let's see that in slow motion to highlight important properties of each state. In the gas state, the particles have so much heat and are jiggling so much that they break free from the other particles. Note that the particles fill the entire volume, bouncing off the walls, the ceiling, and each other. The particles move quickly and randomly, but in reality, gas particles are usually much more spaced out, but that would require a really big container. As we reduce the shaking, effectively cooling the particles, we move into the liquid state. It can take a little practice to get this just right. Now the jiggling is no longer large enough for the particles to fully break free from the forces which hold them together. Note that the liquid state takes up a smaller volume and that none of the particles are reaching the ceiling, but particles still mix randomly amongst each other. Finally, we cool the system by reducing the shaking even further, but don't stop completely. We see that the particles still jiggle slightly, but they return to their original position instead of moving around. This is the solid state, where they are now fully bound by the forces holding them together. Note the pattern that the particles are resting in the solid state. This is similar to the patterns which are formed in many actual solids. At the end of the activity, ask the students to draw their models of each state of matter and highlight the important features that they have identified.